Hello again, and welcome back to Algebra 2 with Miss Faust. Today we're going to be looking at a practice performance task, also known as work sample. For Algebra 2, this one is about quadratic functions, so this will give you a sense of what a sample problem looks like. I'm going to work through this one, and as I do it, you should write down your answers, and then on the back of this page, you'll see there's another practice task that's very similar. So I'm going to tell you sometimes if you want to pause and go do the task on the back and come back, you can do that. Or if you want to just go through the whole thing on the front with me and then do the back on your own, that's fine too. You can always go back to spots in the video if you need some extra help. So, my name is Miss Faust. Let me put that at the top in case anyone tries to take credit for my work later. Okay, so we've got baseball. The height of a pop fly can be described by the function h of t equals negative 16t squared plus 80t plus 3.5, where h is the height of the ball at time t, and we know the ball started 3.5 feet off the ground. So that's this 3.5 at the end. We don't actually have to do anything extra with that in the problem because it's already incorporated into the equation. So what I like to do for these, and you don't have to do this, but it doesn't ever hurt. So it's starting 3.5 feet off the ground, so maybe that's about there. I'm just going to sketch a quick graph so I can make sure my answers make sense at the end. So I know that if you hit a pop fly in baseball, it's going to go up and it's going to come down again. So probably what I'm going to be looking for is I'm going to be looking for this highest point or vertex, and then I'm going to be looking for when it hits the ground. So that's when h of t is 0, is when the ball hits the ground. I haven't actually read the problem yet, but I'm pretty sure that's what it's going to ask. Actually, I have read the problem, but you know, I'm pretending to be you. Okay, using this equation, determine the time it took the ball to reach its highest point. So the time it took to reach the highest point is going to be this part right here. And if I look at that, that's the vertex. So I'm going to need the x coordinate of the vertex to answer that part of this question. So my equation is h of t equals negative 16t squared plus 80t plus 3.5. And in order to find the x coordinate, I have to do x equals negative b over 2a. Well, in this case, b is 80, so I'm going to do negative 80 over 2 times negative 16. And I got to remember to do the 2 times negative 16 at the bottom first. That gives me negative 32. So I'm going to do negative 80 divided by negative 32, and I get 2.5. So that tells me that it took 2.5 seconds to reach its highest point. At the end of this, I'm going to go back and make sure my answers are in complete sentences. I'm just going to show you all the math stuff first, and then we'll talk about the work sample requirement type stuff. So we've got this 2.5 seconds. That's the time it took to reach the highest point. If you want to pause now and go to the back and do question 1 for that problem, you could do so. If not, let's keep going. So part B says what was the maximum height? So again, I think about this equation. Well, if I want to know what the maximum height is, that's going to be the y-coordinate of this. So for part B, I'm going to take this 2.5 and put it everywhere I see a t. So my vertex is at 2.5 and something, and that something is what I'm going to find right now. Sorry, that point got messy. 2.5. Okay, so h of 2.5, or the height at 2.5 seconds, is negative 16 times 2.5 squared plus 80 times 2.5 plus 3.5. Well, 2.5 squared is 6.25. Remember, you have to do exponents before you multiply. 80 times 2.5 I can do, that is 200 plus 3.5. So I need to do negative 16 times 6.25 is negative 100. So negative 100 plus 200 is positive 100. And then another 3.5. So what that tells me is that the maximum height of the ball is 103.5 feet. Yeah, it tells me feet right here. So my vertex is at 2.5 and 103.5. So I've now done part A, I've done part B. If you want to pause now, sorry, I'm trying to keep the contrast from getting all messed up. If you want to pause now and go on and do question 2 on the back, you can do so. You should now be able to do the time it took and the maximum height of the human. And now I'm going to go on to part C. So how long does it stay in the air? Well, if I think about that and I look at my picture, how long it stays in the air is whatever this time is to this time. So I know this time is 0. I just need to figure out what this time is, right? Because the ball stays in the air until it hits the ground, which is here. So I see here I'm letting h of t be 0. So I'm going to take the equation again and just replace the h of t with 0. So I'm going to say 0 equals negative 16t squared plus 80t plus 3.5. And I look at that and I realize because it has this negative 16 in front, I don't want to factor it. I don't want to complete the square. I can't use square roots because it has this, so I have to use the quadratic formula. So this is my A, this is my B, that's my C. So x, or t in this case, t equals negative b plus or minus the square root of b squared minus 4 times negative 16 times 3.5 all over 2 times negative 16. So t equals negative 80 plus or minus the square root of 6,400 minus 4 times negative 16 times 3.5 is negative 224. And that would be negative 32 on the bottom. By the way, I have a calculator just off screen if you're wondering how I did that so fast. It is not my amazing mathematical skills. I don't waste my time on simple arithmetic. I do that with a calculator using my tools. Sorry. Work samples are very exciting. I get really worked up about them. Worked up? Haha, work samples. Okay, back to this. 6,400 minus negative 224 is positive 6624 over negative 32. So carrying on from there, I get negative 80 plus or minus whatever the square root of 6624 is. Whoops, delete. 81.38. I'm going to make that 39 just to have decent numbers to work with over negative 32. So at that point I can split it, and t is either negative 80 plus 81.39 over negative 32, or t is negative 80 minus 81.39 over negative 32. So negative 80 plus 81.39 is 1.39 divided by negative 32 is negative 0.04. And negative 80 minus 81.39 divided by negative 32. Please be positive. Yes, 5.04. So those are the two answers that I get. I look at both of those and I think about the fact that I can think about the graph again. I want to know when it hits the ground. I don't want to know when it would have been on the ground before we started. I want to know where this point is. So that's going to be the positive one. So I can say it takes 5.04 seconds to reach the ground. So that's my answer for C. So now I've got all of the answers here. What I'm going to do is I'm going to go back and I'm going to double check them, right? You're going to double check them. If you look at the back of this worksheet, or at this problem, the last question always says explain your thinking and verify your answers. So explaining your thinking and verifying your answers means that you do actually need to go back and do the calculations again. Some people like to show them a second time. If you don't want to show them a second time, that's okay, as long as you write that you checked them and you write why they make sense. So I'll do a little sample of that here. If I have enough room, I'll do it all in this box. If not, I might have to go to another piece of paper. So the vertex for this function is at 2.5 and 103.5. So I know the ball reached its maximum height of 103.5 feet after 2.5 seconds. I double checked these calculations, and the numbers seem reasonable. Now, you don't want to just say they're reasonable if they're not. For example, if this had been 2,600 feet and you're talking about a baseball, that's not reasonable. But 103 feet is reasonable for a baseball. 2.5 seconds is reasonable for the amount of time it was in the air. I still need to explain this second part, this quadratic formula part. So I'm just going to get another sheet of paper and do it on there. If you run out of room, you're always welcome to use more paper. So that's my first part of the explanation. And then I'm just going to write continued. Okay, so the ball was in the air for, what was it, 5.04 seconds before it hit the ground. And I would double check these. I already did the problem one time, so I'm not going to have you wait while I do the calculations again, but you do want to actually double check them and make sure that makes sense. The other thing that I can say for this is that 5 seconds makes sense because the ball took 2.5 seconds to reach its maximum height. It should take a little more than 2.5 seconds to get back to the ground, because it started 3.5 feet above ground. So the idea there, and this picture can help explain that, the ball started a little bit above the ground. It took 2.5 seconds to get to here. It's going to take 2.5 seconds to get exactly back to this point again. That's the way gravity works. So 2.5 seconds up, 2.5 seconds there. That's 5 plus a little bit more gets us to our 5.04 seconds. So all of our answers make sense. I have shown all of my work clearly. I have verified my answers by doing the problem twice, so I am good. And if you look at this checklist, so this part, I talked through this. You don't have to write these exact sentences. These are just suggestions. Start by saying what I know is, what I need to figure out is, I'm going to solve the problem by. Find the vertex, find the time when h is 0. Use any method, but you're going to use the quadratic formula. Draw a graph. Again, not required, but a good thing to do to help show your work and explain it. Put your answers in a complete sentence and explain why they make sense in the context of this problem. So you're double checking your work and you're explaining why your answers make sense. That's a really important part of a work sample, and that's what people mostly don't pass because of. It's because they didn't go back and they didn't check their answers and they didn't talk about whether their answers make sense. So good luck to you. Please come to class next time with this human cannonball task done. I'll have an answer key for you so you can check it. And when you've done this successfully, then I know you will rock when you get the real work sample. And then you'll have one work sample done and you'll be well on your way to graduation. Yay! Thank you. Have a great day.